Okay, this video is over the mole in class review that we didn't get time to do all of it in class. So this video is for problems 6 through 10. So this one right here, I know I don't have it numbered, but it is number 6. All right, so the question is, how many grams are in 2.8 e to the 23rd molecules of CO2 or CO gas? So anyway, we're starting off with molecules. So you have to look up here and we have to figure out, well, we have to get to grams. And so if we have molecules here, we have to have molecules diagonal from it. So if we look, this one has molecules in it, and so does this one. But we don't want to go to atoms. Atoms is kind of a dead end. So what we want to do is we want to choose this one. We want to go to moles. Okay, so we're going to put that right there. So first of all, see how I have the units diagonal from each other? Okay, so we're going to go to moles. Okay, next. Okay, we want to go to grams, okay? So we look and we find the gram conversion factor. Say 1 mole equals blank grams. Now, does the 1 mole go on the top or the bottom? Well, remember we want to follow the principle of diagonality, so the 1 mole has to go on the bottom. So we would write it this way. Okay, now the molar mass of carbon, if you add it up, we have carbon is 12, oxygen is 16, that's 8, that's 28. So the molar mass of CO, carbon monoxide, is 28. So that's what you would write right here. So if you were setting up the picket fence, you would go 2.8 e to the 23 molecules. You draw the picket fence and you say, okay, I have molecules here, I need to have molecules down here. So you look, this is the one that works because it has molecules and you want that on the bottom. And so the number has to follow it. You can't change the numbers around. So 6.02 e to the 23rd molecules, and then the 1 mole goes on the top. You can't change the numbers in front of these things. Okay? We don't want moles, we want grams, so we're going to go diagonal. Again, it's 1 mole. The molar mass of CO is 28 grams of CO. You do all the math, and it equals around 13 grams of CO. All right, next one. Find the moles in 3.5 liters of H2 gas. Okay, so this is a gas at STP. We have liters here. We have to have liters on the bottom. Well, there's only one conversion factor dealing with gases that has liters on the bottom. So it would go right there. Now, we want to know the number of moles. Oops. We want the number of moles, so here we have the word mole. Well, here we have moles, so we're going to stop. 3.5 times 1 divided by 22.4. That equals 0.16 moles of H2. Okay, next problem. How many grams of CaCl2 are required to make 250 milliliters of a 0.8 molar solution? Okay, this is a solution, so we're going to use these conversion factors down here. All right, so what you would look at is you'd say, okay, I'm going to start off by writing the volume down because, oops, I kind of goofed up. You want to write the volume down because the molarity is the conversion factor. So you always start by writing the volume down. Okay, now we have milliliters here, so we got to find one with milliliters on the bottom. Okay, well, you got it written like this, but basically one time this can go on the bottom or this can go on the bottom. Depends how you want it, but in this case, we need the milliliters to go on the bottom. So we're going to put it there. Now the molarity goes on the top, and the molarity is 0.80, so I would write that 0.80 moles, and it's moles. Don't put capital M there because it actually means moles. Okay, we got to do one more step because we're trying to get grams. Right now we're in moles, we want to get to grams. So you look at these conversion factors. Do you see any with moles and grams? Yes, this one. Moles has to go on the bottom because you're keeping it diagonal, and the number in front of moles is 1. You want grams on the top. So you would choose this conversion factor right there. See how moles are diagonal from moles? Okay, now we got to do the molar mass of CaCl2. So we have CaCl2. So there's 1 calcium, and it's about 40 grams if I remember right. we have 2 chlorines, and each one of those is about 35.5 grams. And so basically, if you add all that up, this is going to be equal to 71 plus 40. That equals 111 grams. So the molar mass is 111 grams for calcium chloride. Then you do the math, and if you do the math, it equals 22.2 grams. Okay, next problem. How many moles are in 2.5 e to the 24th atoms of mercury? All right, so we would look, well, we have atoms here. We want to go to moles. So we're not using the solution ones. We're using these over here. So we have atoms and we want to go to moles. Is there anything with atoms and moles in it? Yes, that's this one right here. Now, what goes on the bottom? The moles or the atoms? Well, obviously, if you have atoms here, you have to have atoms on the bottom. So you want to use this one right there. And notice that our unit on the top is moles. That's how we know, hey, we're looking for moles. Oops, I better not move that. We're looking for moles, so we need to stop when we have the unit that we want on the top. So this times 1 divided by the 6.02. And it actually works out, I believe, to 4.2 moles of mercury. Okay, this one is kind of a long problem. How many atoms are in 25 grams of magnesium hydroxide? Well, we have grams here. We have to have grams diagonal. We look, there's only one conversion factor with grams in it. We want the grams diagonal, so we have to put it in this way. 1 mole equals blank grams. Moles goes on the top, grams goes on the bottom. Now we got to figure this out for MgOH. This is kind of a hard one. Okay, so we got 1 magnesium, and it's around 24.3. So that's going to equal 24.3 grams. See, we got 2 oxygens. 2 oxygens times 16, that equals 32. And we have 2 hydrogens. 2 hydrogens, each is 1. 2 times 1 is 2. If you add all that up, I believe it equals 58.3 grams is the molar mass. So I'm going to write that in right there. I don't want to do that. All right, so back to this. 58.3 grams is the molar mass. Okay, next, we're not looking for moles, we're looking for atoms. So now we got to go look up here and find one with moles and atoms in it. We know we have to have moles diagonal for moles, so that only allows us to use one of these 3 conversion factors. So we want this one right here. So notice how I'm going to keep the moles diagonal from moles. Okay, now the next thing you need to think about is MgOH2 an atom, molecule, or formula unit? See, it's more than one atom, so it's not an atom, and it starts with the metal. That makes it a formula unit. So now we have formula units, but we want atoms. So we look for a conversion factor with formula units and atoms in it. That's this one down here. So we're going to put it this way. Notice how when I use this one, how I kept the formula unit diagonal from the formula unit, the principle of diagonality. Now we have to add up the atoms in MgOH, which we kind of did that over here. 2 hydrogen, 2 oxygen, and 1 magnesium for a total of 5 atoms. So 5 would go right there. Then we would do the math, and we would get 1.3 e to the 24th atoms, if I push the buttons right. Okay, that's it for that video.